Welcome back to yet another coding video. Today we are going to solve Leetcode question 1838, which is the frequency of the most frequent element. So without wasting much time, let's get into the problem statement. So the problem statement here mentions that the frequency of an element is the number of times it occurs in an array. You're given an integer array nums and an integer k. In one operation, you can choose an index of nums and increment the element at that index by 1. Return the maximum possible frequency of an element after performing at most k operations. So what the question here states is that suppose we are given an array. So for example, I am taking an array 1, 2, 3, 3, 3, 4, 4, 5. So in this array, if you look closely, then for element 1, we have a frequency of 1. For element 2, we have a frequency 1. And for element 3, we have frequency 3. Now why 3? Because in this particular array, element 3 occurs 3 times. 1, 2 and 3. Similarly, for element 4, it occurs 2 times. 1 and 2. So frequency, that is the number of times a particular element or a particular number occurs in an array or a string, is called its frequency. So for 4, the frequency here is 2, and for 5, since it occurs only once, the frequency is 1. Now coming to the second part of the question is that you will be given an array called nums and an integer k. So we will be given an array called nums and an integer k. And what we have to do, in one operation, we can choose an index of nums and increment the element at that index by 1. So for example, we are given an array called 1, 2, 3. So what we will do here is, in any one operation, we can pick any of these elements. So we can either pick a 1, we can pick a 2, or we can pick a 3, and we can increment its value by 1. Okay, so for example, if we pick 2, then if we in one operation, if we increment its value to 3, that is by 1, then our new set of array becomes 1, 3, 3. Okay. Similarly, if you pick 1, then the new set becomes 2, 3, 3. And you can do this at most k number of times. That is, you have at most k operations where you can pick any element and increment its value by 1. So what you have to do, doing these series of operations, you have to return the maximum possible frequency of an element after performing at most k operations. So what this means is, for example, again taking the same example, if we have array 1, 2, 3, 4, for example, and let's say our k is equal to 2. That is, at a time you can only you can only perform 2 operations when you will be selecting any 2 elements, either different or the same element, and you will be incrementing it by 1. And after you're done with these series of operations, you have to return the frequency, the maximum frequency of any element that is possible. So for example, for this particular array, if I decide to pick 3, okay, so what will happen in first operation if I decide to pick 3, or suppose if okay, let's pick 3 only. So what will we do? 1, 2, and we'll increment 3 by 1, so it becomes 4 and then 4. And the k here then becomes 1 because we used one operation. Okay. Now, even if you increment any of these two, either 1 or 2 by 1 again, that is going to give you a max to max either 2, 2, 4, 4, or it will give you 1, 3, 4, 4. In either of the case, the maximum frequency that we have is always going to be 2. So there are multiple optimal ways to get it. You can either do it this way, or you can just use 1k operation and get it done this way. But the answer in this case is going to be 2, because we can only increment one element. Now try to understand this one thing. Why did we not choose 4? And why did we choose 3 or 2 or 1? Now if you choose 4, okay, if you choose 4, then it would increment to 5, correct? So we don't have any other element in this array which we can increment to 5. So if we take this 4 and then we increment it to 5, or say if we use both the case and increment it to 6, in that case we are only widening the gap that is between this element and the rest of the elements. So we are just increasing the number of ones that we might need to find out the maximum frequency element. Okay, this is one thing to note. Now the second thing, we can only perform the addition operation. Okay, we cannot perform the decrement operation. So we cannot say, okay, if you have 1 2 3 4, you know what, convert this 4 to 3. That is not allowed. Here it is clearly mentioned that we only have to increment the element at that index by 1. So we can only increment. Okay, we can only increment. So what is the first thing that comes to your mind? It will be the best to perform any algorithm on this set of array if the array is sorted. Okay, so for this, like in this instance, I've already taken a sorted array. But even if you are given an unsorted array, the first thing that you are going to do is sort the array. Okay, why sorted array? Because in a sorted array we will know exactly which elements to increment and which elements to consider. Okay, now coming to the second part of this problem, which is something very important. Let's just take a little bigger array and let's just say, okay, 1 2 3 4 5 6 and 7. Okay, this is the array that we are considering, and let's take k to be 6. Okay, now this is a sorted array. Okay, so maybe we were given this in an unsorted order and we'll just sort it. Okay, the second thing that comes to your mind is, let's just only consider this one. Okay, let's just only consider this one. So for this one, do we need to change anything? So for example, we don't have this rest of the array, we only have one, and we have any k. Okay, any k greater than 0. Okay, even if you have 0, whatever operations you perform on this. Okay, so for example, if you have k 6 only and you just have this array 1. Okay, so even if you make it 2 3 4 5 6, use all of your k's, use all the ones that your k provide, and make it 7 also, or you use less than what is there and make it 6 or 5 or 4, whatever it is. This is the single element in an array, and the maximum frequency that we are going to get out of this array is only going to be 1, because there is only one element. Okay, now let's consider this subarray. Okay, 1 comma 2. Okay, so for this 1 comma 2, that is this subarray, and for example we have k is equal to 6. Okay, what can you do here? What can we do here? Okay, so for example, if we make this 1 as 2, so our array will be 2 2. Okay, the maximum frequency in this case is going to be 2. That is again the length of the array, the length of the subarray that we are considering out of this array. Okay, so just forget that these elements are in existence. Okay, let's just say that only these two elements are there in the array. We have k is equal to 6. We convert 1 to 2 by using one operation from k, and it becomes 2 2. Now the maximum frequency here is going to be 2. Okay, the maximum frequency here was 1. Okay, even if you make this a 3 using 1k operation, and then again you make it 3, this one also using another k operation, the frequency is always going to be 2. You're always going to try to make all the elements in this subarray equal to one particular element, which is the highest element in the subarray. Got it? Okay, if now you consider 1, 2 and 3, this part of this subarray, forget that these elements exist. K is still 6. Okay, what can you do here? So here if we try to make 2 as 3 and 1 as 3, and is it possible? Yes, because for making 2 3 we will need 1. Okay, for making 1 3 we will need 2. So in total we'll need 1 here and we'll need 2 here. So in total we'll need 3 operations. Okay, 3 number of ones. Do we have 3 available? Yeah. So using 3 operations we can make it 3 3 3, and the frequency here would be 3, the maximum frequency. So do you see a pattern here? If you now choose 1 2 3 4, if you now choose 1 2 3 4 and you try to make every element equal to the highest or the maximum element in an array, that is 4, what are you going to get? 4 4 4 4. Does it allow? Because for converting 3 to 4 we will need 1. For converting 2 to 4 we will need 2. For converting 1 to 4 we will need 3. So 3 plus 2, 5 plus 1, 6. Do we have enough number of operations? Yes. So frequency in this case is going to be 4, again equal to the length of the subarray. So this brings us to a conclusion that if we consider any subarray of a sorted part, we need to convert all its row element to the maximum element in the subarray or in the array. And second is, do we have enough number of operations for performing this? Okay, for converting this. If yes, the maximum frequency or the answer is always going to be length of the subarray that we are considering. Okay, so this is the intuition behind this problem. It's very interesting, and also this one forms a basis for a lot of other questions. There's one more very interesting approach about this problem, which is the second approach. We'll discuss that also. But first, looking at this problem, okay, does it not look a little like sliding window? Can we use sliding window on this array to find out the maximum frequency? And why I am saying sliding window? Because at every point you will be considering a subarray. Okay, you will be considering a subarray and you will be finding the maximum frequency that is possible. So let's just get into the two-pointer. The two-pointer approach or the sliding window approach for this problem is very simple. We are going to take 2 pointers. One will be the start pointer, which starts from 0, that is the first element, and the second is going to be the end pointer or the moving pointer, which also starts from 0, that is the first element. And similarly we'll have k, which would be 6, and to calculate or to keep a track of the maximum frequency, we'll use one more variable called result, which will initially set to 0. Okay, now considering the same array. So okay, 1 2 3 4 5 6 and 7. Now both start and end are pointing to this element 1, and because we already know that subarray of length 1, whatever may be the k, is always going to give a highest frequency of 1 only. So what we'll do, we will just calculate the length here. So what will be the result? The value of result will actually be end minus start plus 1, and in this case the end is 0, the start is also 0, so this will be 0 minus 0, that is 0 plus 1 and equal to 1. So result will have a length of 1. Okay, next, then what we'll do, we'll also keep two more variables, one being maximum sum and the other being current sum. Now what is this maximum sum? So as we discussed above here, that for every subarray, we always need to find out the maximum element, and we need to find out how many k's we will need to convert all the other elements into that maximum element. Okay, so after transformation of 1 2 3 into 3 3 3, what is the sum of this array? It is 3 into the length of the subarray, that is the maximum element into sum of this maximum element into length of this subarray. And what is the sum of this array? The one that was before the transformation, it is 6. And what is the sum of this array? It is 9. So the max sum, our max sum at each point will denote the maximum sum that we need to reach, that is the array of end into, so let's just consider this as array, into the length of a subarray. And what would be the length? The length would be end minus start plus 1. Okay, and the current sum is always going to be the next element that you track added to the previous current sum. So for initialization, let's just take both of these as 0. Okay, so now when you are at 1, when both your start and end is at 1, your maximum sum becomes, the maximum element here is 1, so your maximum sum becomes 1 into the length of the subarray that we are considering, which is end minus start plus 1, which is 1. So the maximum sum here is 1. The current sum is also 1, because this is the only sum, the only element that we have. Okay, so now what we'll do, how the next question is, find out the number of ones that we will require to find or transform the array. And how will you find that out? The answer to that is max sum minus the current sum should be less than or equal to k. Only after this element is this value is less than or equal to k, you will be able to convert this array. Like for here, the maximum element was 4, so the maximum sum would be 4 into 4. That is the maximum sum, the maximum element into the length of the subarray. So that gives us 16. And the current sum would be 1 plus 2, that is 3 plus 3, 6 plus 4, that is 10. And this value is equal to 6, which is less than or equal to k. So because we have enough number of moves to support this transformation, we will get the highest frequency a 4. Okay, so see, similarly, this is how we'll be calculating at the end of each iteration. So at the end of first iteration, what we have is maximum sum is 1 and current sum is also 1. So 1 minus 1 gives us 0, and 0 is less than or equal to k is equal to 6, which is why I said previously that doesn't matter what k is, for a subarray of length 1, the frequency is always going to be 1. And here we have already updated the result to 1. Now since this condition holds, we might have a chance to consider a subarray of greater length than 1. So what we'll do, we will just increment the end pointer. So now our end pointer stands at 2 and the start pointer stands at 0. So this is the subarray that we are considering. Again, changing our maximum sum. What does the maximum sum here becomes? The highest element, the maximum element, that is 2, into the length of subarray, that is n minus start plus 1, that is 1 minus 0 plus 1, that is 2. So the maximum sum that we will need to convert or transform this one into the maximum frequency array will be 4. And the current sum here becomes 1 plus 2 is equal to 3. So this condition becomes 4 minus 3, that is 1, is still less than k is equal to 6. So again we can consider a greater length subarray. So we'll move our end to 3. Okay, so the end now becomes 2, the start still remains at 0, and the maximum sum here becomes 3 into 3, 9, because this is the subarray we are considering. And the current sum becomes 3 plus 3 is equal to 6. Now this thing here becomes 9 minus 6, which is still less than or equal to 3, which is still less than or equal to k, which is 6. So again this condition holds. Again we'll increment our end to the next value. So we are considering this subarray now. Again the maximum sum here becomes 4 into 4, that is 16, and this one becomes 6 plus 4, that is 10. So again here 16 minus 10 is 6, which is still less than or equal to k. So we can again move end to 4, that is this subarray. Now the maximum sum becomes 5 into 5, which is 25, and the current sum becomes 10 plus 5, which is 15. This condition now becomes this condition now becomes 25 minus 15, and this value is 10, which is actually now greater than k. So we do not have equal or enough number of moves to perform a transformation of this subarray, that is 1, 2, 3, 4, 5, into something like 5, 5, 5, 5. Okay, so because we cannot do that, what are we going to do now? We need to remove some elements from the beginning of the array, because the maximum difference is always going to be between this element, that is the ending element, and the starting element of the array or the subarray that we are considering. So we will need maximum number of ones to convert this particular element into the maximum element. So what we are going to do now, this condition, whenever this condition holds false, that is when we'll be moving our start pointer to exclude some elements from the beginning. So we will just move our start to 1, and now we are considering 2, 3, 4 and 5. So now our new max sum becomes 5 into 4, that is 20. Okay. One more thing. While we were moving end, we forgot to update result. So every time we were moving end, I think until 4, the result would be 4. 4 plus 1. Here it would be 3. 3 minus 0 plus 1, 4. And then for 5, we were out of this condition. Okay. So the maximum result until this time would be 4. Okay. And here the maximum sum now becomes, since we are considering this subarray, it becomes 5 into 4, that is 20. And the current sum, before incrementing the start, we need to remove this element from our current sum. So that becomes 40. Okay, so the current sum now is 14 and the max sum is 20. So now the condition is 20 minus 14, which is equal to 6, again less than or equal to k is equal to 6. So we again have enough moves for this particular subarray. Okay, so when we have enough moves for this particular subarray, what are we going to do? Again, updating our result to 4, but since we already have a length of 4, we'll only update the result when this is maximum, when we get a length that is greater than the maximum result that maximum length that we have in the result. Okay, so the current is now 14 and this condition holds. We are just going to increment the end pointer again, making it point to 6. Okay, so this is the new subarray that we are considering, and the max sum here becomes 6 into 5, which is 30, and the current sum becomes 14 plus 6, which is 20. Okay, now again here it's 30 minus 20, which is 10, which is now greater than k. So we again don't have enough number of moves for this particular subarray. Okay, so when we don't have enough moves, what do? What we'll do is we'll again decrement the current start element from this current sum. So this gives us 18 and we'll move the start pointer to point to 2. Okay, so then we are pointing to this. So now we are considering this subarray. The maximum sum becomes 6 into 4, that is 24, and the current sum becomes 18. So here again 24 minus 18 is going to give us 6, which is less than or equal to k. So we have enough moves. So this is the subarray we are considering, not updating the result because it is already 4, the maximum that we could have. So we will move the end pointer to 6, that is to point to 7. Now we are considering this subarray. The maximum sum becomes 7 into 5, that is 35, and the current sum becomes how much? For this particular, we'll just add a 7. This becomes 25. Okay, now come back here. What is it? 35 minus 25. This is greater than k. The answer here is 10. So we cannot do this operation. We cannot consider this subarray. Correct? What we'll do? Because this condition holds false, we'll remove 3 from this, which was the starting element. The start is at 2. So we'll remove 3. This becomes 22. We'll move the start pointer to this subarray. Okay? And now the new one becomes 7 into 4. That is 28. And this is still 22. So 28 minus 22 is less than or equal to k, that is 6. Okay, so this is the subarray that we are considering, not updating the result again, but because this condition holds, we'll move the end pointer to the next element, which now goes beyond the length of the array, and the loop stops. So the maximum length, the maximum result, the maximum frequency we are getting here is 4. Okay, so the answer, our answer in this case is actually 4. Okay, now I hope you understood the intuition behind this. It's not a very difficult to point a problem, but once you get this trick, then it's easy. Before you get this trick, it is actually considered a medium difficult problem. So yeah, coming to the time complexity. Okay, so now the time complexity for this, what will be the time complexity? Okay, since we are first sorting the array, it's going to take n log n, and also because we are only iterating in a single pass, then the time complexity would be n. But because of sorting, the time complexity here becomes big O of n log n. There are some operations or some particular functions in different languages that can actually minimize the sorting complexity, but even in the worst case, it's going to be big O of n. Okay, now coming to space complexity. What is the space complexity? We are not using any extra space, but the sorting operation here might be using some space, so this becomes log n. Okay, so this is the time complexity and the space complexity for this particular problem. And now just let's look at the code. Okay, with the code, I'll be solving it on the Leetcode platform itself. You can give it a try first. So you first practice and then you look at the solution. Okay, so we'll start by declaring our variables. So we'll just declare our pointer variables first. So we'll just declare our start and end. Then we'll declare our max sum and our current sum. Okay, then we'll also declare our result value to 0. We'll initialize all these values to 0. Okay, now our loop will run from 0 until the length of the array or the size of the vector, and then inside this we will update our max sum. And what is that going to be? Our nums of n, that is the maximum element. Okay, first things first, I forgot to do this one. I forgot to sort the array. So you first need to sort the array. Okay, so I'll just write it. Sorry for that. Start and okay, yeah. Now our nums of n would be the maximum element, okay, into the length of the subarray that we are considering. Okay, and then similarly we will be updating our current sum value to nums of n, that is the last element that we find while iterating. Okay, now adding the conditions. And what was our condition? If maximum sum minus the current sum is less than or equal to our case value, then what are we going to do? In this case, we are going to increment our moving or our end pointer. Else, what are we going to do? We are going to first decrement or subtract our element which is being pointed by the start pointer from the current sum. So we are going to do minus is equal to nums of start and plus nums of end. Now can anyone tell me why I did this? I'll answer this question. I did this because at every iteration we are already updating the current sum by adding the last element, which is why I removed it here, because if I don't remove it along with the start one, again when we start iterating, the end will be added 2 times. Okay, and the second thing is moving the start pointer. Okay, now at the end we will be updating our result. Okay, minus start plus 1 and finally we'll return our result. Okay, This looks good. Let's just look at it once and try to run the test cases. Okay. Okay, I just made a mistake in naming the variable, and now it should be good. Okay, all our cases failed. Why? Because the output we were expecting in this case was 4, it came out to be 3. Here it was 3, came out to be 2. Okay. Oh, okay. So we'll be returning result minus 1, because here it will always be adding an extra 1. So we need to remove that. This should work fine now. Okay, so it is accepting all the test cases. Cool. So let's just try to submit it and see if it passes all the test cases. Oh, okay. There's a runtime error. Integer overflow. Represented. Line number 9. Okay, oh, since we are multiplying and our max sum is int, okay, it cannot accommodate. So basically it's the integer overflow case, where this value for I think for really big values, this is not able to accommodate, the int is not able to accommodate the product, so we will just convert it to long int. Okay, also these, and also our result. Just try to run. I should have used that test case, but okay, that's fine. Yes, and our code got submitted. So yeah, that was it for this video. Let me know if you want the second approach for this particular problem, because that is also very interesting. So yeah, that was it for this video, and I'll meet you in the next video. Bye bye, take care.